Okay, so this is another U sub. So we're going to do cup. So C stands for what I care about. I care about what my U is. I care about what my du is, my dx, and my x. So then, again, usually what I tell you is, okay, what's the trickiest part about this problem? This looks tricky. Pick what's on the inside, make that your u. But what you really want to do is you want to rewrite it to be cotangent of x over 4 to the 7th power, and that use that same rationality. Ask yourself, what's the trickiest part about this problem? This. And so then pick what's on the inside and make that your u. And think about it. If you make x over 4 your u, everything after that to get to your dx, nothing's going to be related to cosecant squared. And so remember the pattern of u sub. The whole idea is that you're going to pick a u that when you do all this jumble stuff, you're going to get a dx whose denominator is going to cancel out this cosecant squared, like whatever it is, right? And so if you just put x over 4, nothing that you can get over here is going to be related to cosecant. There's no trig here. It's just x over 4. It's just going to be numbers and like a variable, right? So that's not going to cancel out cosecant squared. So it doesn't make sense to make x over 4 u. And so that's why when you have trig, rewrite it this way, because we know we can rewrite it that way. And then use that same rationality and make this your u. Okay, so that's why I'm going to go ahead and make my u that. Okay? So then at this point, what is the derivative of cotangent? And we times that by dx, right? The whatever's here. So I take this little table from, let me search the name of, I think it's called Cole's Worlds of Mathematics. I got it from her YouTube channel. So the idea is you have secant, secant, and then cosecant, cosecant. This one's negative though. And then you have tangent and then cotangent. And then the arrows point inwards. And the whole idea is if I want the derivative of cotangent, that's just going to be these multiplied. So cosecant squared with a negative. So negative cosecant squared x over 4. And because chain rule and there's stuff on the inside, you want the derivative of what's on the inside. That's going to be 1 over 4. But I'll go ahead and show you the step. If you have x over 4, that's really, you're taking f of x, g of x. So the chain rule is f prime g minus f, not chain rule, excuse me, quotient rule, f g prime g squared, because this is a quotient. When you have a fraction, you do quotient rule. And so this is really, f prime of x, g of x, but I don't write it that way because it's just easier to write it, or faster to write it this way. Then I write my stuff here. And so my f of x, right, is my top function. This is my bottom. So x 4, derivative of this is 1. And so derivative of this is 0. And then you put everything together. So you have f prime is 1 times g, which is 4. That just becomes 4. And minus f, which is x, and g prime is 0. So this just is 0. So we have 4 over, and then g squared is 4 squared, which is 16. So that's going to be 1 over 4, which is this, right? So essentially, you could do this, or you could just recognize that out of 1,000 problems that you do, if you have something of this, like this, just take out the x, 1 over 4, right? Okay. So that is me showing you the steps. Okay, and then dx is you take this and solve for x. If you have a fraction, then obviously that means to get rid of that, you have to multiply. So 4 du, and then you have a negative, which is the same thing as this, and then divide by cosecant squared x over 4. And then I don't solve for x. When it's trig, I never solve for x. So u is put everything in terms of u. It's indefinite, so there's no bounds to convert, so we're good there. So then we have this, I made my u. So it's going to be u to the 7th times cosecant squared of x over 4. And I know it's not in terms of u, but remember, the whole point is dx is going to have something that cancels out this. And so we have a negative 4 du divided by cosecant squared x over 4. And look, these cancel out. Isn't that beautiful? So you're left with this, and then because these are all being multiplied together, you could take this constant out to the front, and then you have such a nice integral. So take the antiderivative plus 1. It's going to be 8 divided by 8. Take out the 1 over 8. Pull it out. U to the 8. All being multiplied by negative 4 plus c because it's an indefinite integral. And then the p in cup is plug u back in. And because we don't have definite u's, we don't have like actual u's, we're just going to plug in the general u, whatever u could be. So we could also just distribute this negative 4 inside here, right? And so that's going to be negative 1/2. Okay, so we have negative 1/2, and then we're going to plug in our u, which is just cotangent x over 4 to the 8 plus c, and that is our answer here.